All right, today we're going to talk about quadratic regression and applications, and we're going to use Desmos with this. So, excuse me, quadratic equations are widely used in science, business, and engineering. So for those of you that are always like, when are we ever going to use this? This you actually use in these fields. So they're commonly used in situations where two things are multiplied together and they both depend on the same variable. So let's look at this first one. It says the graph below represents the expected profit Y for given each ticket price X at a concert. So what I did already is I went through and I highlighted, in a sense, some important points that we'll need and be able to interpret it. So we want to know, at what price are the tickets the most profitable? Well, price is your X value. So we're going to look at that, and if you want the most profitable, you're going to use the vertex. So let's look here. This is the highest point, and this is at 9. So at $9 is when we're going to make the most money or the most profit from it. And then it says, what is the maximum, and cross this out, and I want you to write profit instead. What is the maximum profit? Because this is your Y, which is profit. So again, maximum profit, we're going to go to our highest point, and we're going to come here, and it's $18,000. Now, at what ticket price is the expected concert profit to be 0? Well, then it makes sense to look at your intercepts, your x-intercepts, because those are your zeros. And here, it's at $2 and $16. So what I want you to do is analyze the situation. You're going to go ahead and do that one. And then now we're going to come over here. We're going to use Desmos to graph this. So from the time Mark Twain wrote the celebrated Jumping Frog in Calaveras County in 1865, frog jumping competitions have been growing in popularity. The function h of t equals negative 0.03 t squared plus 0.6 t models the height of one's frog jump. So let's go ahead and I graph this here, or I typed it into Desmos here already. And all you've got to do is, once you type in your equation, let's touch, just like I highlighted the problems on the last one, you're going to go ahead and you're going to touch some of those important points. So we've got 20, we've got 10 comma 3, and that's your 0, that's your starting point. So now once you analyze those points, we know the vertex was 10, 3. So it says, when did the frog reach its maximum height? So when is your x value? And we said the vertex was 10, 3. So that makes sense that you have 10 here because it's the when, which was your time. And then how high the frog jumped was your height, and that was your y. And in this case, the vertex was at 3. So our answer is 3. And then it hit the ground at 20. Now I want you to notice when we go back here, I have a 0, 0, and I have a 20. Well, it doesn't make sense because we started at 0, 0, so we're going to throw that 0 out, and we're only using 20. So that's why your answer here is 20. All right? So now for number 2. In baseball, the flight of a pop-up may be described as y equals negative 16t squared plus 80t plus 96, where y gives the ball's height above the ground in feet as a function of time. So you've got height in time, so you've got your x and you've got your y. So it wants to know, what's the baseball starting height? So when you're looking at your graph, what is the c value or what's the y-intercept? So that's what we're looking here, is your y-intercept. So once you've got that, you enter in your equation. You're going to look for your y-intercept, and that's going to tell you where you're starting. And then it wants to know, when did the baseball hit the ground? Well, your ground is your zeros, but you may not be able to use all your zeros. You can only use the one that makes sense with this situation. So in your graph, if you're to have this, we only use the one over here. We don't use the one from before. And then when did the baseball reach its maximum? So when is time. So you're going to look at your x value on your vertex. And then what is the maximum height? Well, height we said was your y value. And you're going to answer that there. All right. For number 3, you're going to go ahead and you're going to complete that. You're going to complete that. And then we're going to go ahead and talk about quadratic regression. So it's a process of a function with best fits a set of data. So before when we did linear equations, we called it the line of best fit. So all you need to do is just follow this set of directions when you log into Desmos. And just remember to hit this plus. You'll enter in a table. You'll enter in this equation. So you hit plus and you'll enter that in again. Here you can type in x equals 10 and it'll show you where it intersects. Or you can just enter in 10 to your equation and it's going to show you what the answer is too, because it's basically a calculator. So I want you to try this with number 1. If you did number 1 correctly, type in these points. If you did this correctly, you should get an answer of x squared minus 16. And that would be the line of best fit for this set of points. You're going to go ahead, you're going to enter in these points on Desmos. And then you're going to go ahead and you're going to enter in your linear regression, or excuse me, your regression equation. And then you'll enter in your answers here. If you did this correctly, round everything to the nearest hundredth, but you should have gotten y equals negative 0.02x squared plus 2.01x minus 20.45. And then let's talk about 3 and 4 on the other side. So for 3 and 4, this is, again, you're going to enter in these points and you're going to enter in the regression equation and you're going to find the quadratic model. When it's asking for the model, you just want to know what's the equation for the line of best fit. So line of best fit or regression equations. So, and I'll erase that just so you know. And then it says use the model to estimate the height of the ball at 2.5 seconds. So that's going to be your y value. So, and you're going to look at 2.5 seconds and you're going to go up here and then figure out what that is. And then it wants to know what's the maximum height. Maximum height would be your y value of your vertex. So again, it's looking at the information and it's interpreting it and using Desmos. And then what you're going to do is you're going to take this information and you're going to plug it into Desmos using your equation. First do your table, then you're going to get your model, your equation there, and then which projectile goes higher and how much higher. So you have two different things. So you're going to graph this one and then straight up in the air of rocket 1 and then rocket 1, rocket 2, graph both of those, and then you're going to figure out which one goes higher, how much higher, which rocket will hit the ground first. So you're going to go through, use Desmos, use those equations, and then look to see what makes sense. And that's how you do quadratic regression and applications with Desmos.